Oh, hi, Professor Gray. This is my assignment 3. The title of this assignment is randomness. The first question is, what does randomness mean? In my opinion, randomness means something unpredictable, unexpectable, and having no identifiable pattern. Randomness is a property of a collection of events or objects, preferably a large collection. Here is an example. A coin toss has two possible outcomes. The heads is a possible outcome and the tail is the other one. The second question is how randomness differs between simulations and games. In my opinion, in a game, randomness is a set of elements that play as unpredictable elements to give players a good feeling and feedback, making them want to repeat playing the game again and again. Because every time the outcome and the result of playing the game is different because of the randomness. For example, my simulation game called Monopoly. Each player needs to roll both dice before moving forward and add them together. Then you need to move your marker exactly that many spaces clockwise around the board. You have no idea what number you are going to get before rolling the dice. The number you are going to get from the dice is the randomness in the game. That's the role of randomness in games. However, in a simulation, randomness has a different purpose than it is in a game. In simulation, randomness is role for measuring or testing. When testing a scientific simulation, it's important to use randomness to reproduce the identical statement execution sequence. Like if we want to simulate a recursion program written by Java, we will use different random numbers as the parameters to test whether the program can reproduce identical statement execution sequence. Here is the third question. Sorry about it. What is the role of time in anchoring events in simulation? And what does the addition of randomness to events mean for the whole simulation process? Time is a trigger of anchoring events in simulation, and the addition of randomness to events make a simulation more unpredictable and much closer to the reality. Time and randomness interact with each other and affect with each other. For example, simulating a system in which clients, like passengers, arrive at a bus stop and wait for a bus. The bus is on a schedule, but if you have had any amount of experience waiting for buses, you would agree that it is still essential arrives at the stop at random. The passengers each wait for an amount of time that is unpredictable, which depends on when they arrive at the stop, and this can be a random value used in the model and the simulation. The fact that buses arrive at random times also affects the amount of time that a passenger waits. If a passenger arrives just after a bus leaves, then they wait a long time. Interestingly, in real life, bus schedules become more random as the day progresses, meaning that wait times become less predictable. This is how time and randomness works on each other. The last question is, how will randomness be defined and what values could be generated? In my simulation, randomness happens anywhere. Because my project is to simulate a game, each player needs to roll both dice before moving forward. As I said before, the number on the dice, it's a number from 1 to 12. Decide how many spaces on the board their makers can move forward, and how many spaces they can move forward decides what property, how many money they will invest. Moreover, what property, how much money they will invest, decide how much money they will earn to recover their investments finally. It's a correlation diagram. Because randomness is the key in this game, and every strategy, including investment, math, finance, is implemented based on those randomness. Yeah, thank you for watching.